In this video, we're looking at evaluating secant and cosecant. In the next video, we'll look at how we can evaluate all six trig functions given any angle in the coordinate plane. Well, that'll be on the next one. So let's start by looking at secant and cosecant. So first, if you need to pause it and redefine your triangle, I just did it in relation to this angle theta, as this being the opposite side, this being the adjacent, and that being the hypotenuse. We did this in class. If you need to pause and do that real quick, go ahead and do that. But let's start by the definition of sine. And cosine. So if we're given this an angle theta, then sine is going to be the opposite side divided by the hypotenuse. So I'm going to write op over hypotenuse. And similarly, cosine would be adjacent over hypotenuse. And so the definition for secant and cosecant, they're not the inverses and they're not the opposites, they're the reciprocals. So here we're taking the reciprocal. And sine is opposite of our hypotenuse. Its reciprocal is what we call cosecant. It's spelled like this. And the abbreviation is CSC. And so cosecant would be hypotenuse over opposite. Cosine's reciprocal is what we call secant. It is spelled there. And its abbreviation is SEC, which means that it would be a hypotenuse over adjacent. So these are the definitions here. These are secant and cosecant. Those are the two that we're going to look at today and see how we can actually calculate those. Because similar with tangent and cotangent, if we have to use these definitions, then what's happening here is that we would have to use a triangle every single time. And if we want to find 7 pi over 4, again, we have to draw a triangle. You have to label the side, all that. We're not going to do that. We will do that on the next video to see any angle in the coordinate plane, but for now, the idea is hopefully we can use this definition, that sine is related to cosecant, cosine is related to secant, and use that definition to actually calculate these without having to draw a triangle. And so what we talked about here, for example, if we need to find secant of 7 pi over 4, excuse me, what we talked about in class is how can we do this? How can we do this using the unit circle and then secant's relationship to cosine? And what students discover, and what we talked about, hopefully hit home, is that secant is ultimately related to cosine. So if I can find cosine of 7 pi over 4, so again, you might need your unit circle here. So if I can find cosine of 7 pi over 4, which is going to be square root of 2 over 2, then secant of 7 pi over 4 is the reciprocal. So here we did it in relation to the sides, but it still applies here. It still means that secant, if I take this fraction and do the reciprocal, that's what secant's going to be. So we need to find cosine first, then take the reciprocal to get the secant. Now from here, when we work through this, some students said, all right, we're good, we're done. Well, not quite, because we need to make sure that the square root doesn't stay in the denominator. So we do need to rationalize here. So 2 times square root of 2, that would give us 2 square root of 2. The square root of 2 times the square root of 2 is the square root of 4, just 2. And then these 2's would divide out, which we're left with just square root of 2. So ultimately, secant of 7 pi over 4 is just the square root of 2. Again, summarizing again. So in order to find secant or cosecant, for example, if we wanted to find cosecant, we could find sine on our unit circle first, take the reciprocal, and simplify. That's exactly what we did here. We found cosine of 7 pi over 4 first, took the reciprocal, and then simplified. That's how we're going to calculate secant and cosecant. Further, what's really nice about this is that we can find all of our 6 trig functions. So let me go ahead and list those here. If you want to list them somewhere else, that's fine. But our 6 trig functions being sine, cosine, tangent, cosecant, secant, cotangent. Those are our 6 trig functions, and hopefully we can recognize that we can actually calculate all 6 of these without having to draw triangles in terms of like radian measures. We can look at our unit circle and use sine and cosine to calculate all 6 of these, which is really great. And we'll use these definitions and properties a lot through this semester. Now, what I would recommend you doing is, based off of our like what we talked about here with secant and cosine, cosecant and sine, I would pause the video, take some time, and actually see if you can summarize how can we calculate secant and cosecant of any radian measure. How do we do it? How do we calculate secant and cosecant here? I would pause it, take 2 or 3 minutes to do that, because that's really going to help you actually understand what's happening, cement your thoughts of what you think is happening, and that's actually going to stick with you longer if you can do that in writing. We did this in class. We spent 3 minutes doing that. It was good. A lot of students did spend time to actually write out what was happening. So I recommend pausing it. I'm going to keep going though, and we're going to go through one. I'm going to give you a solution here. So here, I gave students time to work on these next 6 in class, and if we wanted to find cosecant of 7 pi over 6, so we need to first look up here. Cosecant is going to be related to sine. All right, so if I can find sine of 7 pi over 6, let me get it straight. Sine of 7 pi over 6, sine is the y coordinate, so that would be -1/2. Cosecant and sine are related in that they're the reciprocals of each other. So I can take the -1/2, do the reciprocal. That gives me -2/1, which simplifies to just -2. Similar thing here with cosecant of 3 pi over 4. I would recommend you try that on your own. What you should end up with is square root of 2. That's what you should simplify to. And now here's the other solutions. -2 for, again, do these on your own, see if you get there. -2, 1, 2 square root of 3 over 3. Try them out, see if you can get there. I do want to talk about secant of pi over 2. So secant is related to cosine. And if we can find cosine of pi over 2, that's going to help us find secant. So if I look at the unit circle, cosine of pi over 2, cosine is the x-coordinate, so that would be 0. And if we want to take the reciprocal of 0, that's really going to look like 1 over 0. And based off our conversation last class, that's going to be undefined. So because cosine of pi over 2 equals 0, secant is the reciprocal, then the reciprocal would be undefined. So I just wanted to highlight that. Try these other 1, 2, 3, 4. If you have questions, please ask me. Remind that through the website, email, in class, whatever works for you. But please ask me questions if you have those. The next video we'll look at how to find all 6 trig functions given any angle.